Hi, my name is Amir Alif bin Shuhariman. My metric number is CE190028. So in this presentation, I will explain about what will you do for this activity. So first of all, we're understanding the protective relay in their theories and their calculation method. And then we perform the connection of relay in three-phase network to investigate the behavior with respect to under voltage and over voltage condition in activity 1. Then we record the operating voltage, which is VO, and release voltage VR in table 3.1 and 3.2, and calculate the resetting ratio KR, which means release value of to the operating value. After that, we perform the connection circuit for inverse time over current relay in activity 3. Then we calculate TC of each different value of load by using formula given. After that, we insert the value that has been calculated in table 3.5. And finally, we observe and research the explanation for activity 4, which is a question.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akil Shadi bin Azim and my metric number is DA190184. And in this part of this video, I'll be talking about what is definite time relay and inverse time relay, and also the connection for our lab execution. So what is definite time relay? Definite time relay is a relay that operates after a definite period of time once the current exceeds the pickup value. The pickup value is the value that we have set for our relay, and so this relay has a current setting range as well as time setting range. So what is inverse time relay? Inverse time relay is a relay that operates with a period of an inverse time. It is roughly inversely proportionate to the magnitude of the actuating quantity. So let's move on to our connection. So right now here we have the component for our definite time relay connection. We have our supply, our voltmeter, and our DTR here, and this is our buzzer. So first what we need to do is we need to connect our red phase to our relay, and then our yellow phase, and also blue phase, and after that we can connect to our voltmeter here to measure our voltage. We will connect between red phase and yellow phase, so we will measure our line to line voltage, and after that our relay here will be connected to our buzzer. So after we've done our connection, we can proceed with our lab execution for our DTR or definite time relay. So now let's move on to inverse time relay. So here we have our components for our inverse time relay connection. Here we have our three-phase supply. This is our circuit breaker, our transformer. This is our inverse time relay. This is our ammeter. This is our R load, and this is our buzzer. So let's continue our connection. First, we need to connect our three-phase supply to our circuit breaker. Red phase, yellow phase, blue phase, and then neutral. After we connect this, we proceed to connect our circuit breaker to our transformer, phase by phase, and then our neutral, and then we connect our transformer in delta connection. After we connect our transformer, we can proceed with our neutral, and then we can connect our red phase to our ammeter to measure the current, and our ammeter will go directly to our relay here, and our relay here will go to our R load here, and then we proceed with the yellow phase and blue phase. Okay, after we connect our relay to our load here, then we proceed to connect our buzzer to our relay, and after that our relay need the power source, so we will take from blue phase here and we'll connect to our relay. We will connect over here and our neutral link. So this is our full connection of our inverse time relay lab execution. So that's all from me. Thank you.
Assalamualaikum. My name is Amirul Akmal bin Zuhaili and my matrix number is DE190203. Next is the result for activity 1. Right here, we can see there are two tables, which is table 2.1 and table 2.2. One is for under voltage operation and one is for over voltage operation. We have seen the connection of the circuit that has been shown by my friend in the previous part, and from that we can get the idea that the under voltage and the over voltage operation has been tested or has been done under the same circuit. So first thing first, we inject 380 volt as our 3-phase supply, or the voltage line to line. And from that amount of voltage, we can adjust whether we want to decrease or decrease it, depends on the operation that we want to test. For example, the under voltage operation, we decrease from 380 volt to 366 volt, and at that time the relay will start to operate, and we name the 366 volt as operating voltage, right? And at the same time, the buzzer will start to make sound, as it indicate that this 366 volt is the critical value for the voltage. And then if you want to turn off the buzzer, we need to increase again the voltage from 366 volt to 377 volts, and we name it as release voltage, because we know at that time the relay will release the contact, so the buzzer will turn off and doesn't make a sound anymore. And then after that, we have done for under voltage operation. So if you want to test for the over voltage operation, we need to set again the nominal voltage to 380 volt, and then from the voltage we increase to 408 volts, which is the operating voltage. And the same thing, the buzzer will make sound. So in order to turn off the voltage, to turn off the buzzer, we need to decrease the voltage from 408 to 402 volts, right? And we name it as release voltage. So not to mention that the KR is the ratio for the release voltage to the operating voltage. So we can simply calculate by divide the 377 volts with the 366 volts, and we get 1.03, right? So for over voltage operation, we calculate the KR by divide the 402 volts with the 408 volts, and we get 0.895.
Hi, my name is Amirul Alif bin Syuhariman. My metric number is CE190028. So in this presentation, I will explain for the result activity 3, which is inverse time over current relay. So in this table, we can see they have a 3 different value of load, which is 7, 6, 5, and 4. Okay, when we set the 3 load to 7, the current that we get is 1.7 ampere. The timer is 8 seconds. For load 6, where the current is 1.4 ampere, the timer is 12 seconds. For load 5 is 1.5 ampere, the timer is 23 seconds. And lastly, for load 4, 0.7 ampere and 48 seconds. So after we can see that the more high value of current, the less time taken. So in this TC, we get by using a manual calculation. So this is a calculation to find the TC by using TC formula, which is 80 divided by current more than square minus 1. So current more than can be found by using 0.5 times IN. IN in this lab where we're using 1 ampere. So for load 7, by using a TC formula, we get the value of TC load 7 is 7.58. Okay, and then for load 5, where we get the value of TC is 20.83. For load 7, the value of TC we get 11.70. And finally, for load 4, the value of TC is 83.33. So that's all from me. Thank you.
As a conclusion, DTR and ITR consist of relay, and we know that relay is commonly used as a protection or switching device that can work or operate both mechanically and electrically. And relay, it has set of contact, which it can be in normally closed or normally open, and some would call it as a break contact or mag contact, right? So it functions to change state from normally closed to normally open, and it has C common in the middle, right? In addition, relay can work or operate in both AC or DC condition, right? So it offers a complete isolation between the active circuit and also the load. And in this lab, we use buzzer, right? So from the lab, it can be concluded that the DTR and ITR can ensure the system safety. So thank you.